Now we're going to do this algebraically. Before we looked at limits graphically, and we were looking for what when we looked at it graphically? The intended height, right? Yeah. So now algebraically, this will be, without graphing it, we should be able to figure it out. So we got to know a few properties of limits first before we can go. So the first one is the sum law. And it's stated the limit of a sum is the sum of the limits. So what does that mean? It means if I have some limit of x goes to, say, a of this whole bracket of f of x plus g of x, I can actually separate them. This is a property. You can actually separate the limits and do it individually. This is what it means. It's up to you, but this is what it means. The sum of the limits is, sorry, the limit of a sum, this is the sum, a limit of a sum is the sum of the limits, right? Is basically find the limits individually and add them up. Yes? Difference. I'm not going to write that one out because it's essentially the same thing. The limit of a difference is the difference of the limits. So all I'd have to do there is put a subtraction there, and then it, you know, it's the same thing, right? So I guess what I'm trying to say to you is you can separate it, right? Okay. The next one is the constant multiple law. The limit of a constant multiplies, no, shoot. Okay. So the limit of a constant multiple of a the limit of a constant multiple multiplied, it should be multiplied by a function, is the constant multiplied by the limit of the function. Okay, I'll explain what I mean there. So the limit of x goes to some number a, I'll say, or c, who cares, of 3f of x. So this is the constant, right? That's equal to 3 times the limit of that function. Meaning you can take the 3 out and multiply it after you find the limit. It'll make a lot of sense when we start seeing what I mean. But essentially, if I have a graph of a function, for instance, and I can find the limit, meaning the intended height at you know, when x is, say, 5, then all I'd have to do is find that height and then multiply it by 3 versus trying to figure out what that is. So it's just a property. You can remove the 3 and put it in front. Okay, so the limit of a product is the product of the limit. Again, we'll do some examples in a second. This is the same thing as kind of like adding and subtracting. If I have a limit of x goes to a of f of x times g of x, like this, I can actually separate it as the two limits. Huh?
Oh, yeah, this is product.
Yeah, this is product. The next one will be divided. So I'm not going to write that one out. But essentially, again, if you have a quotient, you can find the limits separately. Okay? Provided that what? When you're dividing, what do you have to watch out for?
They don't equal 0.
Yeah, that the denominator does not equal 0, right? So if the function value is 0, then you can't actually calculate it, right? Like the denominator. Okay, the power law. If we use the product law repeatedly, that's the limit of a rational. Like if I go 5 times 5 times 5 times 5, that's the same thing as 5 to the power 3, right? That is the limit of a rational power, is the power of the limit. Meaning, if I have the limit, again, of x goes to a of f of x to the power, I don't know, 4, that's the same thing as taking it out, finding it separately, and having that to the power 4 like that. And again, when we do these couple questions, it'll make sense, right? So here's a graph. Here's all the heights in there, right? But sometimes we can't find certain things unless we actually apply those property rules. So, for instance, F is pink, right? And G is the blue. Does everybody see that? I know yours isn't colored, but it's labeled kind of for you. So the first property says that the limit of these two added up can be separated. So I can actually say the limit as x goes to -2 of f of x. Does everybody understand that? Plus, now this is a constant times a function. That one said that I can take the 5 out and put it in front. So 5 times the limit as x goes to -2 of g of x. Does everybody see what I did? I used those properties to basically expand it. It's kind of like from like 40 pre-cal. There were certain properties for logarithms that you could expand and stuff. It's kind of similar to this, but it seems like they're a little bit more generous of what we can do for limits. So now let's look up, what is the limit of f of x when x goes to -2? The limit as x goes to -2, yeah, it's 1. Do you see it's right there? It's 1. Or it's the intended height. So it's 1 plus 5 times, what is the limit as x goes to -2 of g of x? It looks like it's -1. So then it would be 1 minus 5, which is -4. Does everybody see now I found the answer? Yep.
You have to write out like all the limit stuff when we pull it apart.
Nope. I'm just showing you how I'm getting this. Yeah. Yeah. Honestly, this would be on a multiple choice. To be honest, it would be on a multiple choice. So you would get the answer -4, or you get something else. You know what I'm saying? So, yeah. Okay. So this is the product rule. So we can separate it. Again, you don't have to show this step, but I'm just going to show that I can separate this, right? So this is the limit as x goes to 1 of f of x times the limit as x goes to 1 of g of x. So what is the limit as x goes to 1? It looks like it's 2 times the limit as x goes to 1 for g. What about that? Yeah. So if this one does not exist, so then what is your actual answer? It does not exist. It's kind of like when we had the 40 pre-cal and we were dividing functions or adding functions, and one didn't exist and we were trying to add it to something that did exist. We just couldn't find it, right? So if part of the limit doesn't exist, you can't actually multiply something by it and get something. Okay, how about the next one? The limit as x goes to 2 of f of x divided by g of x. So here's 2. F of x is the pink. So it's something like that, right? I don't know. What do you say it is? 1.4? I don't know. But the thing that's coming up is kind of, what is that? 0. And you can't divide by 0. So what does that mean? Does not exist. Yes?
For B.
Well, we could say undefined, actually. But anyways, yeah.
For B, for the G.
Okay. So here's another one. Is the limit of a constant is just the constant. And why do you think that would be? Does anybody remember what a graph of a constant looks like? A constant function? Yeah, well, it's not just a straight line. It's just a horizontal line right there. So does everybody see, if I find the limit, it doesn't matter which x value I'm finding, that height is going to be the same no matter what, right? So does that make sense why that would be? Okay, and then it's saying here, if x goes to a, and this is, what does this x mean here? What kind of function is that? That's that diagonal line, right? So what's so unique about that diagonal line? The height equals whatever the x is, right? So when x is 1, y is 1. When x is 2, y is 2. When x is -1, y is -1. Do you see? Why, when it's just equal to x, it's that? Okay. So We're going to use the limit laws to evaluate. I'm going to show every single step, but at some point you're just going to fly past this, right? Okay. So I'm going to separate everything. So this is going to use all the limit laws. So I'm going to take out the 2, and then it's going to be the limit as x goes to 5 of x squared.
Yeah, what did you just do?
Of what? Like example 2?
Everything.
So the 2 is going to come out front. Then I'm going to have the limit as x goes to 5. X, and remember the power, I can find the limit of x first, and then I can square it, right? Then subtraction can be separated as the limit as x goes to 5 of x, and then I can separate it again, the limit as x goes to 5 of 4. So all I'm doing is separating them all. So what's the rule I just said here? The limit as x goes to 5 of x. What do I get for a value there? I get 5. For this value here, I get 5. Yes? This is this thing here. When x is 5, the height is 5. Yes? So I should get 5 for that. Then I have to square it and times it by 2. So what do I get? 50. What do I get for this one right here? 5 times minus 3, so it will be minus 15, yes? And what do I get for this? The limit of the constant, doesn't matter what it's going to, it's always going to be the constant. So what is it going to be? It's going to be 4. Because there's no x in there, so it's not a variable, right? It's a constant, yeah? So 50 subtract 15 is what? 35, 39? Somebody check my math. Okay, so I'm going to show you a shortcut because these properties are a little bit ridiculous, hey? Guess what you could have done as a shortcut here?
Skip the
Guess what happens when you just plug 5 into those x's? You get 2 times 5 squared minus 3 times 5 plus 4. So what do you get? 39. So, so if it asks you to use the limit laws to evaluate, then you're supposed to do it this way. But honestly, again, this would be on a multiple choice, and I would just be looking for an answer. So do it however you want to do it. You just need to figure out a way to get the answer. The long way, you'll see, is obviously way more complicated to see, but the justification is there of why the answer is that, right? So yes, if you go to the shortcut, that would work at this point. Okay? So do you want to do the next one then? So what would you do there? Yeah, no, do the shortcut.
Okay,
Do the shortcut for this one. This one would be crazy to write out actually, but
yeah.
I'll do the long way while you do the shortcut, okay? Okay, so you should get negative 2 in there to the power 3 plus 2 times negative 2 to the power 2. Subtract 1 over 5 minus 3 times negative 2. So you get negative 8 plus 8 minus 1 over 5 plus 6. So negative 1 over 11. Did you get that? Okay. The sandwich or the squeeze theorem. You see this, you might see this like once on the AP exam every 10 years, so I'll teach it just to make sure you remember it, but honestly it's not that big of a deal. If we can't find a limit directly, we may be able to find it indirectly with the squeeze or the sandwich theorem. And it basically says if you can find the limit on one side of the function and the other, then it's basically squeezed or sandwiched in there. Okay? I'm just on the next, I think the next, well, maybe I'll show you this one. So for instance, if I had some function where it was going like, I don't know, like that, and then I had a function that was, say, the x squared function and the negative x squared function, do you see that if I could find the limit somewhere of a height and they're both the same, so I probably drew that wrong. I should have had it so that the x squared and the negative x squared met at 0. So if the height is both the same and the function is sandwiched between the two, then that means it would have to be that limit at that spot. So we'll do this here. So everybody has their graphing calculator. We're going to graphically find this. So grab your graphing calculator. Okay, so I go to y1 and I punch this in, and then I'm going to go, so I'm going to make sure my mode is in radians. This course is all in radians, so make sure yours is. Okay, then go zoom trig, which is 7. Oh, look at that beautiful thing. Something's going on here. You can't really tell. I don't know. So we're going to use, now notice when you plug 0 in here, you get 0 squared, and then I have sine of 1 over 0. You can't find sine of 1 over 0. You can't divide by 0, right? So that means I can't find the limit, and you might say, oh, well, then the limit doesn't exist. Well, in calculus, when you least expect something to not exist, it actually, if you zoom in here, you'll see that something's going on in there. So now I'm going to go to y2, and I'm going to punch in x squared. And then y3, I'm going to punch in negative x squared. And we're going to graph it, and you'll see that it is sandwiched in there. So you can't really see what's going on there, so I'm going to zoom into this window here. Now, does everybody remember how to zoom in? So you got to change, you can zoom in, just go zoom in. I'm going to change my x value so that they're between pi and negative pi. So here's negative pi, and enter, and this is pi. This is in my Windows settings. So now it's a little bit more zoomed in. I could even zoom in more. So I'm going to zoom in even more because that doesn't even help me much. So I'm going to go to my window, and maybe I'll do negative pi over 2. Did anybody find one that was a good window setting? You just kept zooming in? Maybe I should just do that already. Yeah, I'm thinking I'm going to zoom in at this point because this just looks a little ridiculous. But you can see it's sandwiching it in between the two functions here. So I'm going to go zoom in, and I'm going to zoom right where it's 0, 0. So do you see, now you can see, now if I had that calculator that changed colors for each line, I could see it a lot better. Because now it's so sandwiched in, you can't even see what's going on there. But I'll show you this again. I'll just, well, I'll change the window setting just a little bit. So let's say it's negative 0.4 to 0.4. You can see the first one's kind of going up and down like that, right? And then we have my x squared going like this and my y squared. So it's pretty clear when x goes to 0, what's my actual limit?
0.
Yeah.
No matter how far we zoom in.
Yeah. So no matter how far we zoom in, it's going to be that. So the limit as x goes to 0 of x squared sine over 1x is equal to 0, since the limit as x goes to 0 of x squared equals 0, and the limit as x goes to 0 of negative x squared equals 0. And negative x squared is between x squared sine of 1 over x is in between x squared. So honestly, they'll probably, this would be a graphing calculator thing, and you would just try to squeeze it and then find, as long as you say using the squeeze theorem. So, okay, so we've already discovered that the fastest way to find a limit is direct substitution. Just substitute whatever number that is into the function to get the height. So, we're going to use direct substitution. However, it only works if it's continuous at A. Does everybody remember what continuous means? You basically can't lift your pencil, right? In order to do this, it has to be continuous. Okay. So, okay, so when you're actually doing direct substitution, sometimes you get something really goofy that shows up. So then you have to do something else. So if I were to substitute 5 in here, what do I get? 25 minus 4 over 5 minus 2, and I get 21 over 3, which is 7. Did everybody get 7? So that's the limit. Works out nicely, doesn't it? So if this were the limit that you get when x goes to 2, say this was the same function, but this time it's x going to 2, and you get x squared minus 4 over x minus 2. What do you get when you actually, you get 0 over 0. And we recognize this from grade 12 pre-cal, right? What does that represent? A hole. This means there is a hole in the graph at that x value. You may want to find the location of that hole. The y value at that hole is your limit. So how do we do that? The first technique is you try to factor and you try to cancel. And this is what we did actually in grade 12 pre-cal, right? So we're going to continue it on the next page as an actual example. So remember, we just subbed this in and we got 0 over 0, right? So we're going to now factor this. So what can you factor? Yeah, the difference of squares. This is x minus 2 times x plus 2 over x minus 2. So what can we cancel? The x minus 2 with the x minus 2. So really this is the limit as x goes to 2 of x plus 2. So what's my answer? 4. Now here's some rules with limits. A lot of people get lazy and they don't write the limit all the time. Until you actually do the direct substitution, you need to write the limit each time. Otherwise you will be docked marks, just so you know, on a long answer. Limit, I didn't substitute the 2 in yet, right? I didn't substitute the 2 in. I did, so it's gone, right? The good news is on the AP exam, most of the limit questions are multiple choice. So it's not like you would lose any marks there. But I'm saying until that point, if I ask you a free response on limits, make sure you get in the habit of always writing the limit until you actually direct substitute that x value in. That's what I'm trying to say. Okay, so so the first step when you're doing a limit, direct substitution. If you get 0 over 0, the technique then is to factor and see if you can cancel. So it's kind of like a little, if this happens, do this. So first thing, sub it in. So let's just sub it in. We get 1 plus 1 is 2, minus 2 is 0, and then we get 0 on the bottom. You don't have to show me that step. I'm assuming you tried it. Because actually what happens sometimes is I'll throw a question in that works with that direct substitution, and people try to factor and stuff like that, and then it gets them nowhere, right? And then they get frustrated, and then it would have just been easy just to direct substitute. So remember, always try to direct substitute. A 0 over 0 is like a huge case for factoring and canceling. So -1, so we subbed it in, we got 0 over 0, so now what do we do? Factor. What is the top factor to be? x plus 1, x minus 2. Is that right? These cancel. You don't have to write the next step. I'm going to write it just so you know. It's the limit now as x goes to negative 1 of x minus 2. Negative 1 goes in there. What do I get? Negative 3. Okay? Yeah, so essentially what this is, if you remember from grade 12 pre-cal, this rational function is really this line, x minus 2, with a slope of up 1 over 1. And then when we get to negative 1, there's a hole. It looks like that. Do you remember those functions that look like that? So unless you graph this, which you wouldn't at this point, because in order to graph this, you would have to factor it anyways, right? So you would end up getting that height of negative 3 in there anyways. Does that make sense? Okay. So you substitute something in, and you get negative 2 in there. You get 0 on top. You put negative 2 in there. You get root 2. Subtract root 2. So you get 0 over 0. So direct substitution didn't work. You look at this and you go, how the heck do you factor it? You can't. So technique number 2, multiply the conjugate. Does everybody remember what the conjugate is? What would the conjugate be here? Yeah, the same thing, but this is a plus, right? So it's going to be root of x plus 4 plus root 2 over root of x plus 4 plus root 2. Yes? Okay, remember I haven't imposed the limit yet, so in the next step I need to actually write the limit as x goes to negative 2. Okay. Am I going to multiply this out? Do I care about the top multiplied? No, it's the bottom that gets me that whatever. But we could, this is a little bit of a messy thing going on here. But really what I want to do in the end is I want to get something good happening on the bottom, because it's the dividing by 0 that's really the problem area, right? So I'm going to leave the top as the same. So it's going to be x plus 2 times the root of x plus 4 plus root of 2 over, what do I get on the bottom? What's root of x plus 4 times root of x plus 4? X plus 4. And then the nice thing about a conjugate is the outer and the inner cancel each other, right? That's the whole point of the conjugate. Root of x plus 4 times root 2 is root 2 root x plus 4, or you can multiply it in. And then you get negative root of 2 times that. Do you see they cancel? And so then you just need your last. So what do you get there? What's negative root 2 times positive root 2? Negative 2. Okay? Do you see why I didn't multiply the top? What's going to happen in a second? It's going to cancel, yeah. So I'm just going to simplify. Again, I'm not multiplying this top. So what do I get when I simplify this? I get x plus 2 on the bottom. Do you see that? And then they cancel. So this is now the limit as x goes to negative 2 of the root of x plus 4 plus root of 2. Now I can sub it in. What do I get in the first one? I get root of 2 plus root of 2, which gives me 2 root 2. So 2 root 2 is my final answer. Okay, direct substitution. We get 9 times 4 is what? 36. Minus 15 minus 21. So we get 0 at the bottom. Does everybody see that? And what do we get on the top? We get 9 plus 7 is 16, root 16. I get 0 over 0. Does everybody see? Quick inspection, I get 0 over 0. Second step, try to factor. Not going to happen on this. So, third step, conjugate. We could factor the bottom. We could try to factor the bottom, and probably eventually we will have to. But the thing is, factoring the bottom will not cancel something on the top because there's nothing to factor on the top. Like the whole point of factoring is to get the same on top as the bottom. So you probably might be just spinning your wheels at that point. So now we were used to the conjugate usually on the bottom, right? But in this case, we're going to use the conjugate of the top because I don't like the square root thing there, right? There's no conjugate of the bottom. Does everybody see that? So I'm going to be doing the conjugate of the top. So 4 plus square root of x squared plus 7 over 4 plus the square root of x squared plus 7. Does everybody see what I'm doing? Okay, so remember, when I do this, I'm only multiplying. This is just like when our proofs were when we were doing that conjugate. We were only multiplying the part that I want to get rid of. So I'm not going to, this would be craziness if I multiplied this into this, right? So I'm only going to multiply the top to get rid of the inner and outer terms. Does everybody see that? So the limit as x goes to 3, and what do I get on top? The first I get 16. Yes, 4 times 4. The outer I get 4 root x squared plus 7. The inner I get minus 4 root x squared plus 7. So they cancel. That's the whole point, right? And then last I get negative root that times positive root that. So I get negative, what? X squared plus 7. I'm putting it in brackets so that you realize that the 7 is now negative, right? A negative times a positive gives me a negative this whole thing. This whole thing was getting rid of the square roots, so it's this whole thing here, right? So I'm going to have, so maybe in this step I may want to factor the bottom. But even then, I'm a little bit leery at factoring the bottom because this might take me way too long. And part of the problem with this exam is you don't have lots of time. It's like you need to like solve it really fast. So unless you can find the factors right away, I wouldn't try to factor it by guess and check. I would like wait until it pretty much shows me what the factors are, because you saw in the last one the factors will end up canceling, right? So I'm going to have 4x squared minus 5x minus 21, and then 4 plus square root of x squared plus 7. So now what do I get on top here? What's 16 minus the whole thing of x squared plus 7? That would be, what's 16 minus 7? 9. So you're going to get 9 minus x squared over 4x squared minus 5x minus 21, 4 plus the square root of x squared plus 7. Okay. So, do we have something here that's going to factor? What do you think? This factors. This is a factor. Does everybody know this factor? Yeah, the difference of squares. So let's do that. This is where I'm saying don't try to factor the bottom until you see the factors of the top, because that'll lead you in the right direction. You know what I'm saying? So limit as x goes to 3. This is going to be 3 minus x times 3 plus x. Everybody agree? Okay, so now the bottom one, I'm not going to, you can't factor this square root one, so I'm just going to write that one. But this is where I'm saying it's going to lead you in the right direction. Because guess what one of the factors are going to be? It's going to be x plus 3 or x minus 3. So let's just see here. So if it's going to be a 3, then that means this has to be a 7. So this is what I'm saying. This saves time now because I know it has to be an x. I just don't know if it's going to be a minus or a plus, right? So then if this is going to be x, this has to be a 4, right? And then I get a 12 and a 7, and I have to have a minus 5, which means this has to be a minus and this has to be a plus. Yes? Does everybody see my logic here? I know that one of the factors is either has to be x plus 3 or x minus 3. Okay? So I put an x and a 3 there, which means this has to be a 7 and a 4x. And then from there, I have to play to make this, right, with the signs. And so that's the only way it worked, right? Minus 12 plus 7 makes the minus that, and that makes a minus. Yep. So then you might say, well, you can't cancel that. Yeah, I showed you this trick, right? This cancels with this, and what do you stick? A -1 in there, right? Okay, so let's plug her in. 3 goes in now. What do I get in top? -6. What do we get on the bottom? We get what? 12 plus 7. Is that 19? And what do I get in this bracket over here? 9 plus 7 is 16. Square root of 16 is 4, so I get 8. And you might say, well, I got to multiply 19 times 8. No, you can cancel 6 eighths down. That makes it a lot easier, right? What does 6 eighths cancel down to? 3/4, yeah? So then this is going to be -3 over 19 times 4 is way easier, right? 9 times 4 is 36, so that's 76. 19 is a prime number. Does everybody know that? So it's not like anything can cancel anymore. 3 doesn't go into 76. Okay, then we have the square root of 0 limits. What's the square root of 0 equal to? 0. Does everybody agree the square root of 0 is 0? Okay, so however, if the square root of 0 appears in a limit, we're concerned about the path it follows because we cannot compute the limit I think I want here. So do you remember when we have square root functions? This is y equals the square root of x. Does everybody see, if I find the value of 0 here, it's 0, right? But the limit as x goes to 0 does not exist. Why is that? Because it only exists from the right-hand side, not the left-hand side. So there is a value for it, a function value, right? And I can do direct substitution and get a value, and then you might think, oh, that was one of the multiple choice. I'll circle it, I'm done. No, if it's a square root function, the limit only exists from one side. So you got to be careful, okay? So for instance, if I do direct substitution in here, I get the square root of 0. However, does anybody remember what this graph looks like?
It doesn't exist.
It's one of these functions that got shifted to the left 2. So you see, that's what it looks like. So the x goes to -2. I know it's going to 0 from the right-hand side, but it's not going to 0 from the left-hand side, so it does not exist. So maybe I'll write that out. The limit as x goes to -2 from the right-hand side, remember how I designate the right-hand side as the superscript plus of the square root of x plus 2? That equals 0, but the limit as x goes to 2 from the left, sorry, -2 from the left-hand side doesn't exist. So because one side doesn't exist, then you can't have them going to the same side, right? So the whole thing doesn't exist. So the key here is the square root of positive numbers coming in means that it's the limit equals 0, and this one means it doesn't exist. I'm gonna explain what this means in a second. So to wrap your head around calculus, when I say I'm coming from the right of -2, what is a number on the right of -2?
More positive.
Yeah, you could say -1, or I could, now remember limits are as close as possible to that -2, right, without actually being it. So you could have -1.9. If I put -1.9 in there and add 2 to it, do you see I'll get positive numbers? And I will then be able to actually evaluate it. If I put something on the left of negative, like say you didn't know what this graph looks like, and a lot of the times you'll forget But if you end up putting numbers that are close enough to that to see what it is, then it's pretty easy. So if I come from the left-hand side, what's a number on the left of negative 2? Say negative 2.1. If I put negative 2.1 in there, do you see I'll get the square root of a negative number? And you know that. A square root of a negative number doesn't exist, right?
Oh, that's not one.
Okay, so now we're doing one-sided limits. You have to be careful. If you just put 7 in there, you get the square root of 0. But remember, the square root of 0, you have to investigate further. This is coming from the left-hand side. So what's a little bit on the left of 7? On the left of, I'm talking about on the number line. Here's 7. What's on the left of 7?
8.
The left. 6. 6 is on the left. Sure. 8 is not. 8 is not. On the left of 7. If I put 6 in there, will I get positive or negative? Positive. So what is this answer? I'll repeat. You can't just tune away for a second. You have to be listening the whole time, right? So if I put 7 goes in here, I get the square root of 0. And I said the square root of 0, you have to be cautious because on one side it exists, the other side it doesn't. So to test it, because this is coming from the left-hand side, I pick a number on the left of 7 and plug it in. And if I get positive, it works. If I get negative, it doesn't work. So I put 6 in because that was on the left of 7. 7 minus 6 gives me a positive number, so I know it exists and it equals 0. What does this graph look like? Does anybody remember? Remember, you have to factor out the negative, and it's a reflection, right? Y equals the square root of negative bracket x plus, x minus 7. Minus 7. So this is a graph that instead of going like this, it's getting reflected and shifting to the left of 7 like that, right? So do you see why it's existing on the left of 7? Yeah? Okay, how about this one?
Let's plug in 7.
If I plug in 7, what do I get? You get the square root of 0, and that was the little danger zone. I got to test further.
From the right.
It has a right-hand side. What's on the right-hand side? 8. 8 is on the right. Here's a number line. What's on the right-hand side of the number line?
6.
Say 8. 8 goes in there. What do I get? I get negative. You can't square root negative numbers, so does not exist. You getting it? Okay, how about this one? Uh-oh. Plug in 6. I get the square root of 0. Investigate. So what you have to do is you need to split it into 2 limits, one from the right and one from the left. Right? Because in order for a double-sided limit to exist, they both have to go to the same number, right? So what do we get here? If you put 6 from the right, what's the number on the right of 6? 7. What happens here? You get 0. What happens if you take something on the left of 6? Say 5. What do we get? It doesn't exist. So what happens here? Doesn't exist. If one side doesn't exist and the other does, the whole thing doesn't, right? Okay. Let's plug her in. Negative 2 goes in there. What do we get? 4. Negative 2 goes in there. What do we get?
21.
14. 4 plus 14 is 18. Subtract 18 is? We gotta investigate. See, we're getting it. Okay, so now it's saying it's coming from the left-hand side. This is the left hand of negative 2.
Negative 1.
Sure, negative 3. Negative 1 would not work. Okay. Plug her in. Negative 3 goes in there. What do we get? We get 9. Negative 3 goes in there. What do we get? Plus 21 minus 18. What do we get? Plus or minus? We get, who cares what the number is? Do we get plus or minus? plus. So that means the answer is 0. It's not whatever this value is. This is just the testing, right?